Let's continue with these multi-step linear equations, but let's make it a little bit harder by putting in a fraction. Fractions tend to make things harder. And let's solve for this problem on a screen. Well, the objective is the same. We start by locating our x, which in this case is on the left side of this equation. And, well, we need to isolate it. That means we need to take care of the 3, the -5, and the 4. One more time, the order is very important. Now, I could simply say that, yes, we need to start with a 4 in the division. And it could make sense. It may make sense. But let's understand deeply why we need to start with that 4 in the division. For that, we rewrite the fraction. So that means let's just focus on the fraction, on the 4 on the fraction. So when a denominator divides everything, that's what is happening here. That 4 is on the denominator of everything on the left side. Everything on the left side is being divided by that 4. We can just take it outside. So we can take that 4 and write it outside. But I mean, it's not just a 4. It's a 4 on the denominator, so we have to keep it in the denominator. We have to write it as 1 over 4. We cannot just simply take it outside of the denominator. We're taking it outside of the fraction, but it stays on the denominator. And then, what about the rest of the equation, the rest of the fraction? Everything else stays the same, exactly as it is. We just took away the 4. Now, this step is not fully necessary. You don't have to do it if you don't want to. This step is just to help us visualize better the situation. Let's clean the board so we can continue solving. And let's take care here. This is a problem now very similar to the problem we were solving on part 1 of this lesson. We have the x inside of the parenthesis. We multiply times a 3, subtracted -5, and there is a number outside of the parenthesis. And as we learned on part 1 of this lesson, we need to start with the number outside of the parenthesis because we cannot solve for x meanwhile there are parentheses. And one more time, this extra step that we did was not fully necessary, but now we can see why we needed to start with the 4 in the denominator. And all we got to do now is the opposite, or the inverse operation. And the opposite of a division is a multiplication. So we need to multiply times 4 in order to cancel the 4's. But if we multiply times 4 the left side, we need to multiply times 4 the right side, leaving us with 10 times 4, and 10 times 4 is 40. Let's clean this up and let's look at this equation. We even learned this once earlier in lesson 3.2. This is a 2-step linear equation in which we have an x being multiplied times a number, in this case a 3, and subtracted by a number, in this case a 5. And we already know we need to start with the addition subtraction. So we start with a -5 and its inverse operation. What is the inverse operation of a subtraction? It's an addition. So if we have a subtracting 5, we need to put at adding 5. So they can cancel. The opposite, so they can cancel. But if we subtracted 5 from one side, if we added 5 from one side, we need to add 5 from the other. 40 plus 5 is 45. Now we reach the final step because we're still isolating that x. But that x is just being multiplied times 3. And we can take care of it because it's the last step, the multiplication. And the inverse operation of a multiplication, we already know, is a division, meaning we need to divide by 3. That way the 3's cancel, but we also need to divide the right side. And 45 divided by 3, this is equal to 15. The x is finally fully isolated. The x is by itself. There are no other numbers next to the x. So the final answer is x equals 15. So one more time. We could have started by just multiplying times 4, times that 4 in the denominator. We start when there is just one denominator for everything on one side of the equation. We can start by multiplying times that denominator. But we followed the process to understand why we needed to start by multiplying times that denominator.